Okay, so in this video we're going to have a look at integration. Now, the aim of the video, we're going to be having a look at obviously integrating functions like the one on the screen right now, and having a look at these more complex pieces that we have to try and integrate and sort of why we do this and how we go about it. So you are going to have to have a good understanding of differentiation for this video, and obviously I would make sure that you've obviously watched that one first, and you're also going to have to have a good understanding of your index laws as well. So I will link all those videos in the description, so make sure that you check those out first. But we're going to start having a look at sort of why we integrate and how we go about it to start with. So let's have a look at that now. So when we looked at differentiation, we looked at this particular graph, and this is the graph of y equals x squared. So we had a look at this and we had a look at how to differentiate that. And when we differentiate it, okay, we multiply the coefficient of x there by the power. Okay, so when we differentiate it, we wrote it like this, dy over dx. There we go, and we multiply the coefficient of x there, which is 1, so we multiply that by 2, so we've got 2x. And then we reduce the power by 1, so we reduce that power of 2 down to a power of 1. And we got this here, 2x. Now when we're looking at integrating, we're essentially looking at doing the complete opposite here. We're just going to reverse this process. So instead of multiplying the coefficient and reducing the power, we're essentially going to increase the power and divide the coefficient. And when we write this out, we write it out like this. Okay, and this little symbol here, which I'm going to have better in a second, but it looks something like that. We say to do the opposite, that means integrate. We put in the bracket what we want to integrate, which in this case is 2x, and then we say dx after that, just means with respect to x. So that just means obviously do the opposite. That means integrate 2x with respect to x, and we're going to look at how we go about actually doing that. So obviously, as we've said, we're going to increase the power. So at the moment, that power of 2x there, the power of x is a power of 1. So if we increase that, it becomes 2x squared. And then rather than multiplying by that coefficient, we're now going to divide by that. Sorry, rather than multiplying the coefficient by that power, we're going to divide the coefficient by that power. And the power is 2, so we're going to divide it by 2. And you'll see when we do 2x squared divided by 2, we get back to that original x squared that we had up the top there. Okay. Now, the problem with this is, and obviously this isn't going to be the final answer here, the problem with this is that there's quite a lot of different graph equations here that are going to give us 2x when we differentiate it. So if I have a look at another example up here, we could have y equals, and let's just imagine it's x squared plus 5. Now when we differentiate that, obviously we multiply the x squared by the coefficient by 2, and we get 2x. So when we differentiate it, we get 2x, and the 5 then disappears. So that gives us 2x as well. Likewise, we could have something like y equals x squared minus 19. When we differentiate that, multiply the x squared by 2, reduce the power, you get 2x, and the 19 disappears. So again, we get 2x. So the problem here with the integration is that we don't actually know what that constant is at the end, what that number is at the end. And because of that, we have to add something onto our answer when we're integrating, and that is that we have to put plus c at the end, and that is called our constant of integration. Again, that just obviously says that we don't actually know what the constant is, so we always have to put plus c at the end, and that's going to be absolutely essential as we move through this video. Every time we integrate, we're going to have to put that plus c at the end, because we just don't know what that constant was unless we have any specific values on our graph. And obviously with the x squared graph, that's quite a nice one, but let's just imagine, just to sort of give you an overview of everything we're going to be looking at, if I imagine that I say, okay, well on this particular graph that we've just integrated, so this x squared plus c, we have an x and a y value. Let's imagine we say, okay, well y equals 5 when x equals 2. Okay, so if y equals 5 when x equals 2, what is that equation going to be? Well, if we sub those values in, x squared is going to be 4, so that would be 4 plus c, and that has to equal 5. So we know in that case there, c would have to equal 1, and the equation of this line in particular would be x squared plus 1, or y equals x squared plus 1. Okay, so that's sort of all the processes that we're going to have a look at. So we're going to have a look at obviously integrating and introducing that constant of integration at the end. And then we're also going to have a look at obviously finding what that constant is for a few questions, and actually showing sort of what the full equation is there, or what y is in terms of x. Okay, so obviously we would have y equals in front of that because if we were finding the equation. So we'd have y equals x squared plus 1 for that particular one if it was obviously 2x that we were integrating, and if we had those two values there that we were able to substitute into it. But essentially, again, as I said, we are going to look at the reverse of differentiation, okay, and it's called integration. We're going to look at going about that process with some slightly harder questions than this one here, but that just gives you a little overview of how we're going to go about it, how we're going to sort of reverse that process, and the things that we're going to do with it in order to find some of these values. Okay, so we're going to have a look at our first question now, but do make sure you've checked out differentiation, which is in the description, and make sure that you're very happy with your index laws again, which I'll put at the top of the description there so you can check that out first. Let's have a look at our first question. Okay, so here's our first question. We're going to integrate 1 minus 3x cubed. And again, obviously just remembering that that symbol just means to integrate, and dx at the end there just means with respect to x. So when we integrate this then, let's have a look. So we've got 1 at the moment, at the start, so we're just going to focus on each piece as we go. So we've got 1 there, and if we increase the power of x there, obviously there isn't a power of x at the moment, or it'd be x to the power of 0. So if we increase that, it would become 1x, and that'd be the power of 1. And then we need to divide by that power of x there, so we're going to divide that by 1, and we'll deal with all that in a sec. It looks a bit weird at the moment having all those 1s in there. But there we go, that's our first bit, and then we'll look at our next piece here. We've got negative 3x cubed, so we're going to take away, and then we're going to do x cubed is going to go up to a power of 4, so we're going to have 3x to the power of 4, and then we're going to divide that coefficient by that new power there, which is a power of 4, so we're going to divide that by 4. Okay, there we go. So obviously we just need to simplify this all down. So at the moment we've got 1x to the power of 1 all divided by 1. Well, that's just x. There we go, 1x divided by 1, and we don't need to write that power of 1, so we just have x there. Then we have take away, and we've got that coefficient there of x to the power of 4, which is a 3, and we're going to divide that by 4, so we can just write that as 3/4, 3 divided by 4. We don't have to write that as a decimal or anything. 3/4 x to the power of 4. And hopefully you've already spotted there's one thing that we need to add into this, and that is that plus c. Okay, and really we should have added the plus c into our working out just there, so not forgetting to add that plus c in. And there we go, that's our final answer. So integrating that, we get x minus 3/4 x to the power of 4 plus c at the end. And again, really important, we don't forget that plus c. That's absolutely essential for us to add that on there. Right, okay, so there's our first question. So let's have a look at our next one. Okay, so something here that looks a lot more complicated, and let's see how we go about this one. So we've got these 3 pieces that we're going to integrate this time. So we're going to start off with this 12x cubed. So again, we're going to increase the power. So we have 12x to the power of 4, and then we're going to divide by that new power, so divide by 4. Then we're going to add to that. We've got 6x, so that's going to go up to 6x squared, and then we're going to divide by that new power, which is 2. And then we're going to take away, and this one's not as nice here because we've got a power of 2/3 there, but we have 15x, and we need to figure out what that power is going to be. So we need to add 1 to 2/3. Well, 1 in terms of thirds is 3/3. So if we add 3/3 to 2/3, we get 5/3. There we go, and that's not a 5, so let's rewrite that. We get 5/3. There we go. So 15x to the power of 5/3, and then we need to divide by that new power. So we're dividing by 5/3. Not very nice there. There we go, but divide by 5/3. And then at the end of that, plus c, okay, because we don't know what that constant would have been at the end. But there we go, we just need to simplify this all down, see what we get. These first two look okay. We've got 12 divided by 4, which is 3, so that's quite nice. We get 3x to the power of 4 for the first bit. The next bit, we've got 6 divided by 2, which is 3 again, so 3x squared. And then this bit isn't so nice here. You've got 15x to the power of 5/3 divided by 5/3. And obviously, if you've got your calculator, obviously you can work this out quite nice and easy. But don't forget, it's not too difficult just to do 15 over 1 divided by 5/3. So times it by the flip version, 3/5. And there you go, that equals 45 on the top over 5, which is 9. There we go, so 15 divided by 5/3 is 9. Just a nice little bit of working out there, obviously not always having to rely on your calculator if you've got some nice quick working out that you can do. So there we go, take away, that becomes 9x to the power of 5/3. There we go, and not forgetting plus c at the end. There we go. And there we go, that's that integrated, okay? Not forgetting that plus c again, that's so important. Obviously something that's obviously new with this, even though we're doing the reverse process of differentiating, that plus c there is so important to make sure that you add on the end. But there we go, that's again how we're going to integrate. So increase the power by 1, divide by that new power, and then simplify all your terms and just watch out for any sort of complications when you've got fractions in the powers there, and just being careful with that. But here we go, here's a couple of questions for you to have a go at. Okay, so here's 4 questions, so pause the video there, have a go at these, and we'll go over the answer in a sec. Okay, so for this first one then, so 3 is going to increase to 3 to the power of x, and we're going to divide that by 1. I'm not going to bother writing dividing by 1 under there. I will do with all the rest, but not when I'm dividing by 1. So the next bit, minus, and we have 5x cubed, and we're going to divide that by that new power of 3, and then make sure we put the plus c at the end. Okay, so simplifying that down, we have 3x, take away 5 over 3, which is 5/3, x cubed plus c. There we go, and there's our first one. On to the next one, depending on which way you've gone, we'll go to the right. So for this one here, increase the power, so we have 9x cubed, and we're going to divide that by 3. Then we've got 6x squared, divide that by 2, and then we've got 1x, and we're going to divide that by 1, so I'm not going to write plus 1, divide by 1, and then we've got our plus c at the end. There we go, and simplifying this down, 9 divided by 3 is 3, so we have 3x cubed. 6 divided by 2 is 3 again, so 3x squared, plus up 1x, which is just plus x, and then our plus c at the end. Right, there we go, so there's our second one. And onto our bottom left one here, let's have a look. Increasing the power, so we get 6x cubed over 3. And then we've got our first fractional power coming in here, so we've got 5x, add 1 to 3 halves, let's have a look, so adding 2 halves to that gives us 5 over 2, and we're going to divide that by 5 over 2, our new power, and then plus c at the end. Okay, so simplifying this down then, 6 divided by 3 is 2, so we have 2x cubed, plus 5 over 2 is 2.5, so 5 divided by 2.5 is 2, so that becomes 2x to the power of 5 over 2. Plus c. And obviously some of these harder divisions here you can do with your calculator, but hopefully you'll be alright with that. Again, you could do 5 multiplied by 2/5, just flipping it over there, gets you 10 over 5, which is 2. Okay, so you can always work it out that way as well, just using your normal rules of fractions. And on to our final question here, we've got 10x to the power of 5, when we increase that, divide it by 5, plus 8x squared, divided by 2, minus 5x, add 3/3 to 2/3, again gives us 5/3, divided by 5/3, plus c at the end, and we'll simplify this down to finish off these questions. 10 divided by 5 is 2, so we have 2x to the power of 5, 8 divided by 2 is 4, so 4x squared, and then we have 5 divided by 5/3, and 5 divided by 5/3, let's have a look, that's 5 times 3/5, which equals 15 over 5, which equals 3. So minus 3x to the power of 5/3. There we go, plus c at the end. There we go, and that's all of those integrated. Obviously not forgetting on each question to make sure you add this plus c on the end. All right, there we go. Okay, so that's the start of our integration there. Let's have a look at what we're going to have a look at next. Okay, so we've got a couple of new elements coming into this particular question here. So it says, obviously, that dy over dx is 7 plus 1 over root x, where x has got to be bigger than 0, obviously because we can't have a 0 on the bottom there. And it says, given that y equals 26 and x equals 4, find y in terms of x, giving each term in its simplest form. So what this is saying here, look, it says this is what dy over dx is, so it's already been differentiated. And in order to get back to the equation of that line, or in other words, y in terms of x, we're going to have to integrate it to do so. And then it gives us a couple of values. It says, look, y is 26 and x equals 4, and that's going to allow us to find that constant of integration once we go backwards. So if we actually go about integrating this, there's one part that we just need to make sure we're very careful on, just like we looked at in differentiation. We've got that root x on the bottom there. So root x is obviously, can be written another way. We can write that as x to the power of a half. And we're going to have a look at obviously writing all this and just being very careful in all the steps as we go. So to start with, x to the power of a half is the same as the square root of x. So if we change that to x to the power of a half, and obviously it's 1 over that as well. So obviously when it's 1 over that can obviously be written as a negative power instead rather than 1 over. So we're going to write this as a single line. We're going to change it to 7 plus, and that'll be x to the power of minus a half. Okay, there we go, minus a half. Obviously thinking about your index laws there, the power of negative a half is 1 over the square root of x. So we're just rewriting that there. Now we can actually go about integrating this. So if we integrate this now, obviously we've got the first piece there, which is the 7. So increase the power, that'll go up to 7x. And obviously dividing by 1, we don't need to write that, so we've just got 7x there. The next one, we have the x, so let's just put plus for the moment. And that power is going to increase to positive a half. So it's going to be x to the power of positive a half. Now obviously that new power is a half, so we're going to divide by a half. There we go. And then we've got our plus c at the end. Now we can go about simplifying this. So if we simplify this down, we get 7x plus, now the coefficient of x to the power of a half there is 1. There would be a 1 in front of it, okay, if we put that in. Now 1 divided by a half is 2, so that's going to become 2. So we have 2x to the power of a half. There we go, plus c. So there we go. Actually, we're almost at a point where we have y in terms of x, because we have our line equation now, or our graph equation, and that is that y equals 7x plus 2x to the power of a half plus c. Obviously this question's actually given us some values. It says y equals 26 at the point where x equals 4. So if we go about substituting these values in, we can say, okay, well y is 26, so 26 has to equal 7 lots of 4, okay, 7 lots of 4 there because x is 4. 7, 14, 20 and 28, isn't it? So 7 lots of 4 is 28, plus then we have 2 lots of x to the power of a half, and I'm going to write this as a bit of working out. We've got 2 lots of, and 4 to the power of a half is the square root of 4, which is 2. So we have 2 lots of 2, and then plus c. And if we just go about simplifying this down, we'll find out what c is. So we have 26 equals, we've got 28 plus 4, which is 32. So 32 plus c. So c has to be negative there. Has to get us back to 26. So what do we add to 32 to get 26? And that's going to be minus 6. So c equals negative 6. There we go. And obviously you'll probably recognise some links between this and coordinate geometry. When we find that value of c, we'll just have to put it back into our line equation or our graph equation. Obviously that will give us what we're looking for here, which is to find y in terms of x. So if we plug this back in, we're basically just putting it back into the place where c is up in that equation there, and we get y equals 7x plus 2x to the power of a half minus the 6. And there we go, there's our final answer. Y is now in terms of x, and each piece is in its simplest form. You could actually rewrite little bits in different ways, like that x to the power of a half there. We could put 2 root x and things like that. But there we go, it's absolutely fine to leave it as a power. We have y equals 7x plus 2x to the power of a half minus 6, finding our value of c. So there we go, that's how we're going to approach one of these questions. Let's have a look at another one before you have a go. Okay, so a very similar process in this question. Again, we've been given this differentiated piece up here. It says dy over dx is 6x to the minus a half plus x root x, where x cannot be, where x has to be bigger than 0. Again, you can't square root. We can't square root the 0 there. So obviously we're looking at values bigger than 0. So it says given that y equals 37 and x equals 4, find y in terms of x. Again, given each term in its simplest form. So again, we want to have to figure out what the graph's equation is here. So we're just going to integrate those pieces up there and see what we get to start with. So let's just rewrite what we've got. We've got 6x to the power of negative a half plus, and we've got x root x. Now again, before I write this out, we've got x and it's being multiplied by, we have x to the power of a half. Okay, and obviously thinking about your index rules there, you've got x to the power of 1 being multiplied by x to the power of a half. You can add the powers together, and that's going to equal x to the power of 3 over 2. There you go, or 1.5 when you add them together. So we have plus x to the power of 3 over 2. There we go, so when you have those root x's next to an x and things like that, obviously you're just thinking about rewriting it in terms of a power and following your normal power rules for that. But there we go, now we can integrate it. So if we increase this first power then, this power of negative a half, if we add 1 to that, it becomes positive a half. So we have 6x to the power of positive a half, dividing by that new power of a half, and there we go. The next piece, 3 over 2, if we add 1 to that, it becomes 5 over 2. Remembering that 1 is just 2 halves, so add 2 halves to that is 5 halves. So we have x to the power of 5 over 2, all divided by 5 over 2. There we go, and plus c. And there we are, that's integrated. We just need to simplify it down. So 6 divided by a half, well a half goes into 6 12 times. So we have 12x to the power of a half. There we go. Plus, and if we divide 1 by 5 over 2, and remember you can write this to the side, 1 divided by 5 over 2 is the same as 1 times 2 over 5. You just flip it over, which just becomes 2/5. So there we go, that's going to be 2/5 x to the power of 5 over 2 plus c. Okay, there we go. So that's integrated, that's our line equation there. We can put the y equals in front of that now. We've got y in terms of x. Obviously we just need to find out what that value of c is there. So if we plug these values in, let's see what we get. So obviously in our question it says y is 37, x is 4, and let's have a look at what we get then. So if y is 37, we've got 37 equals, and we've got 12 lots of x to the power of a half. Again, I'm just looking at this equation down here and just rewriting it up here with the numbers. So we've got 12 lots of x to the power of a half. Now x is 4, to the power of a half is the square root of that, so it's 12 lots of 2. Add to that, we have 2/5 of whatever this x to the power of something is. Now the x is to the power of 5 over 2. Now that 2 on the bottom square roots it, remembering 4 to the power of 5 over 2. Let's write this down over here. 4 to the power of 5 over 2. So we're going to square root it to start with, which is 2. And then we're going to do that to the power of 5, because there's a 5 on the top. 2 to the power of 5 is 32. So there we go, we've got 2/5 of 32. And then we've got the plus c at the end. And we just need to simplify this down. Now you've probably already spotted that 32 isn't going to nicely be divided by 5. It's not going to give us a whole number there when we find 2/5 of that. So we are going to get a decimal involved here, but that's okay. Let's just follow the process. So we have 37 equals 12 times 2 is 24, and then 2/5 of 32. Now 32 divided by 5 on the calculator is 6.4. Timesing that by 2 to get 2/5 gives us 12.8. So we have 24 plus 12.8 plus c. There we go. And if we add this all together, let's see what we've got. We've got 37 equals 24 plus 12.8 is 36.8. There we go, plus c. So our c value there, what's missing is 0.2. So c equals 0.2, or you could even write that as 1/5. There you go, well, 0.2 or 1/5. As it's all fractions down there, I might just keep it as 1/5, but obviously you can write it as either, they're both the same, so 0.2 or 1/5. Then obviously it just wants us to write it as y in terms of x, so we're just going to plug that value of c back into our equation here for that value of c. So for the final answer we get y equals 12x to the power of a half plus 2/5 x to the power of 5 over 2 plus 1/5 or 0.2 there, either one. Okay, so there's our final answer. Obviously, just showing you the final part of this process here. So we've integrated it, we've got our plus c at the end, and obviously we've subbed in the value of x there to make it balanced to find our value of c, and then rewritten that graph's equation. Obviously just writing it with a fraction there rather than a decimal, but you could write it with either. But there we go, that is what we're going to have a look at next. That's what you're going to have a go at. So let's have a look at a couple of questions. Okay, so here's your 2 questions, so pause the video there, have a go, and we'll go over the answer in a sec. Okay, so for this first one then, so at the moment we just need to integrate this and then we'll have a look at the next part. So integrating that then, we get 3x to the power of 3 all over 3 minus, and we get 3x to the power of 2 all over 2 plus 5x, and we increase the power there, plus c at the end. There we go. So obviously then simplifying this down, we get 1x cubed there, 3 divided by 3, so x cubed. Take away 3 over 2 x squared plus the 5x plus c. There we go. Right, so subbing the values in them, we've got y equals 10 when x equals 2. So if we go and sub these in, let's see what we get. So we've got 10, well, we could have put the y equals here as well, but we get 10 equals, and we get 2 cubed there when we sub it in x equals 2, so we get 8 minus 3 halves of x squared there, which is 4, there we go, plus 5 lots of 2 plus c, and we just need to make this all balance out. So we've got obviously that 3 over 2 lots of 4, so half of 4 is 2, times it by 3 is 6, so we have 10 equals 8 minus 6 plus 10 plus c, and we can finish that off. 8 take away 6 is 2, plus 10 is 12, so 10 equals 12 plus c, and then we're going to get our value of c there as having to be negative 2. There we go, so obviously just simplifying that down, we get c equals negative 2. So let's just get rid of part of this. Let's remove this bit here, just so we've got a bit more space. There we go. Right, so we get c equals negative 2 to make that all balance out. And then we just need to write our line equation there, which is y equals x cubed minus 3 over 2x squared plus 5x minus 2. And there we go, that's that one finished. There we go. Okay, so on to our next one. We have to integrate this obviously again. So let's have a look. We've got 6x to the power of a half. So that's going to be 6x to the power of, and add 1 to the half becomes 3 over 2. And then divide it by 3 over 2. Plus, and we need to sort this bit out now to start with. So we have 5x that's being multiplied by x to the power of a half. There we go. And if we add those together, we get 5x to the power of 3 over 2. Okay, just adding those powers together, obviously the power of 1 and the power of a half. So that's going to be 5x to the power of 5 over 2 when we add 1 to it, and then divided by 5 over 2. And then that's the end of our little piece there. So obviously simplifying this down to on the next part here, so we get 6 divided by 3 over 2. That's the same as 6 multiplied by 2/3. Obviously you've got a calculator here, it's nice and easy. 3 over 2 is 1.5. That fits into 6 4 times. So it's going to be 4x to the power of 3 over 2. I'm going to add to that. 5 over 2 is 2.5, and that fits into 5 twice. So that's going to be 2x to the power of 5 over 2 there. And there we go, plus c. There we go, almost forgot to write the plus c on the starting part there. There we are, so that's our line equation, or our graph equation, y equals that. And then we just need to sub the value in just like we did before. So in this case we have y equals 90, x equals 4. And if we sub those in, we get 90 equals, and we've got 4 lots of x to the power of 3 over 2. So 4 lots of, now x is 4, so we need to do the square root of that for the 2 on the bottom, which is 2, and then cube it, which is 8. So we go, 4 lots of 8. Plus, we've got 2 lots of 5 over 2, x to the power of 5 over 2, so square root it again is 2, to the power of 5 is 32, so 2 lots of 32, plus c, there we go. So simplifying this down then, we get 90 equals 4 times 8 is 32, plus 2 lots of 32, which is 64, plus c. There we are, so we have 90 equals 96, that's not a 9, 90 equals 96, plus c, so c has to equal -6. There we go, so we've got our value of c, and then to finish it off, we just have to plug it back into our line equation just there, or our graph equation. So if we get rid of this bit, and we'll write that all out. To finish it off, we get y equals 4x to the power of 3 over 2, plus 2x to the power of 5 over 2, minus 6 at the end there. And there we go, there's our final answer for that question. Right, okay, there we go. So we've obviously looked at integrating parts. We've looked at obviously here reversing, differentiating and subbing values in to get the actual original equation. And now we're going to have a look at just integrating some slightly harder pieces before we get to our final question. So let's have a look at those now. Okay, so this one isn't particularly any harder than the ones we've looked at. It just doesn't quite look as nice. And we have looked at some pretty horrible looking ones already. So hopefully you'll find these okay, but just some slightly different looking questions to have a look at. So it says find, and then we have the integral of what's in the bracket there with respect to x, okay, giving each term in its simplest form. So if we go about integrating this one, let's just have a look at what happens. So we have the first piece there, which is 6x squared. So again, increase the power, we get 6x cubed. Divide by that new power, so divide by 3. Now the next piece, we're going to have to rewrite this, and this is where this is just a little bit different to ones we've looked at before. This piece here, and we have looked at obviously 1 over, but now we have 2 over. So 2 over x squared there, we can rewrite as, let's write it over here, 2x to the minus 2. There we go, and that is obviously just 2 over x squared. Okay, you can obviously always think about the 2 on the top as being 2x to the power of 0, and on the bottom you've got 2x squared, sorry, just x squared. And then obviously you can just subtract the powers there, so you get 2 divided by the 1 on the bottom, which is 2, and then x take away the 2 is minus 2, there we go. So it's just another way of writing it. Obviously thinking about those little bits of indice rules there and how to rewrite these, but there we go, that's that rewritten. So we have 2x, and if we increase the power by 1, it goes to minus 1, and then divide by the new power minus 1. So again, just watching out on that there. Obviously that negative power, make sure you're careful when you add 1 to that, and making sure it goes to minus 1 there and not minus 3. And on to the final piece, we've got the 5, so plus 5x, obviously divided by 1, so we won't write that. And again, plus c at the end. There we go, almost finished then. So simplifying this down, that first piece there, 6 divided by 3 is 2, so we get 2x cubed. Then we have 2 on the top there divided by negative 1, so that's going to be negative 2, so negative 2x to the minus 1, plus the 5x, plus c at the end. And there we go, that's that integrated as well, finishing that question off. Right, there we go. So obviously, just because it looks a little bit harder, don't be put off by that. You're just going to be careful with those little pieces. And this was the piece here. Obviously, just to be careful on remembering these little bits of working out that you can do to the side as well. There we go. Let's have a look at another one. Okay, so very similar to one that we've looked at before. We've got this root x on the bottom in the middle there. So we're going to integrate this again with respect to x, given each term in its simplest form. So for the first piece there, let's have a look at obviously doing that bit first. That's quite nice and easy, that one there. 2x to the power of 4. So we get 2x to the power of 5 divided by 5. Take away. And then we've just got to rewrite this second piece here. So this 4 over root x. Now again, root x on the bottom can be written as x to the power of a half. We've met that before. And obviously it's 4 over that. So we can write it as 4x to the power of minus a half. And again, just thinking about the working out for that, you could have 4x to the power of 0 divided by 4 again. I was almost sure it did that last time. There we go, x to the power of a half. And when you subtract the powers there, 4 divided by 1 gives you 4, x to the power of, and you get minus a half when you subtract the powers there. So obviously just thinking about that working out again, if you don't really like rewriting those. But there we go, we get 4x to the power of minus a half. So increase the power by 1, we get 4x to the power of positive a half, divided by that new power of a half, and then again, plus 3x at the end. Right, there we go, plus c to finish that off. So simplifying this down, we've got 2 divided by 5 there, so we'll write that as 2/5, x to the power of 5, minus, we've got 4 divided by a half, so that's 8, 4 divided by a half is 8, x to the power of a half, and then we just have our 3x and plus c at the end, and there we go, that's integrated again. There we go, we're finished. Okay, so just obviously a few little things to look out for. Obviously when they don't look very nice like this in brackets, don't let that put you off. Obviously just follow all those little rules of indices that we've looked at, and obviously just making sure that you're very careful then, simplifying all those pieces down and not sort of making any mistakes in those final steps there. But there we go, that's our sort of final question to have a look at in terms of these. Here's a couple for you to have a go at. Okay, so here's your 2 questions. So pause the video there, have a go at these, and then we'll have a look at our final question. Okay, so looking at these then. Now that first piece there, we've got 8x squared, so that'll be 8x to the power of 3 all over 3. Then we have the next piece there, which we just need to rewrite, so that becomes 3x to the power of minus 4. So increasing the power there, that becomes 3x to the power of minus 3 all over the new power, minus 3. And then we've got plus 9x and our plus c at the end. And then finishing this off, simplifying that down, 8 over 3 is 8/3, so 8 over 3x cubed. 3 divided by negative 3 is negative 1, so minus x to the minus 3, don't need to put the minus 1 in there, plus 9x plus c. And there we go, there's our first question finished. There we go, on to our next one. Let's have a look. We've got one piece to rewrite there, but let's do that first bit to start with. So increase the power of x cubed, we get 3x to the power of 4 over 4, minus, and then we'll sort this piece out here. So root x is x to the power of a half, it's 2 over that, so it's 2x to the power of minus a half. There we go, 2x to the minus a half. So increasing the power goes to a half, so we get 2x to the power of a half divided by a half, minus 5x plus c, and let's simplify that down. So 3 over 4 is just 3/4, so 3/4 x to the power of 4 minus 2 divided by a half there is 4, so 4x to the power of a half minus 5x plus c, and there we go, that's that one finished. There we go. Right, these questions seem actually relatively simple once you've done some of the previous ones and seen all those little pieces there. Hopefully it's all just sort of tying together and you're getting sort of happy with all these little things. Obviously, just a little note, the little pieces in here can be written ever so slightly differently. Just like 4x to the power of a half, this sort of piece here could be written as, well, obviously negative in front of it, 4 root x. Okay, obviously x to the power of a half can be written as 4 root x. Like that. So obviously just thinking about there are different ways of writing little pieces here, and obviously not worrying about that too much. I'm just going to leave it in terms of the powers there rather than rewriting them and spending a little bit more time. But they can be written like that, obviously, as we've seen from the question. If we see x to the power of a half, we can write that as a root x if we want, and that's absolutely fine to do. But here we go then. Let's have a look at our final question before we finish. Okay, so this question here looks very similar to one we looked at earlier in the video. We've got dy over dx equals x squared plus 5 in brackets squared all over x squared, where x cannot equal 0. Obviously we can't divide by 0, so we can't have x is 0 on the bottom. And it says given that y equals 13 and x equals 1, find y in terms of x, giving each term in its simplest form. So obviously you've got a few little bits to sort out here. You've got a bracket on the top that needs expanding. You're going to have to turn this into a single line, so dividing all of those pieces by x squared and getting those obviously rewritten. But obviously you need to get that into a single line, integrate it, sub these values in, find that value of c. So have a go, see if you can get this question done, see how far you can get. We'll go over the answer in a sec, so pause the video there and have a go. Right, okay, so we need to sort out what's on the top to start with them. So x squared plus 5, obviously squared means we've got to do a double bracket, so we have x squared plus 5 and another x squared plus 5. There we go, so if we expand this all out, we get x to the power of 4, and then we get plus 5x squared plus another 5x squared, so that's plus 10x squared. There we go, and then 5 times 5, we get plus 25. So that's what we've got on the top, and that's all being divided by x squared. So obviously we just need to then divide all of these powers by x squared. It's actually not too bad if you've obviously got to this point already. The first piece there, x to the power of 4 divided by x squared. Well, I'll subtract the powers, we get x squared. There we are, the next piece, 10x squared divided by x squared is just 10, so plus 10. And then the last piece there, 25 divided by x squared. Well, subtract the power from x to the power of 0, gives x to the power of minus 2. So we get 25x to the minus 2. There we go. And now it's at a point where we can actually integrate it. So if we bring this up and integrate that, let's see what we get. So x squared, well, we'll obviously increase the power, so we get x cubed divided by 3. There we are. Plus 10x, increasing the power of x there. Obviously there was no x before, so we'll introduce the x. And then for the last piece there, if we increase the power, it goes to minus 1. So we get 25x to the minus 1 divided by the minus 1. And then we get plus c at the end. Right, okay, so nearly done. We obviously just need to simplify this down. So we get at the start there, we can obviously write it as a third if you want. You've got 1 in front of the x cubed there. So we've got 1/3 x cubed plus 10x. And then we have 25 divided by minus 1, so it becomes minus 25x to the minus 1 plus c. And now we can go about subbing these values in. So it says over here, y equals 13 at the point where x equals 1. So if we obviously write this as an equation now, let's just get rid of this because we could have put our y equals at the start of that one. Obviously have decided not to as we were integrating it at that point, but now we're looking at it in terms of y equals y in terms of x. We can write that out. So we've got minus 13 is equal to 1/3 times 1 cubed, so 1/3 times 1, which is just 1/3. You can put the 1 in if you want, let's just write that in anyway, 1 cubed, plus, then we've got 10 lots of 1, which is just 10, take away 25 lots of 1 to the power of minus 1. And there we go, 1 to the power of minus 1. You can put in the bracket, and then plus c. Right, so simplifying this down then, we've got minus 13 at the start obviously, equals, and we have 1/3 times 1, which is 1/3, plus 10 times 1, which is 10, take away 25, and then 1 to the power of anything is 1, so it's just take away 25, plus c. Obviously we just need to obviously simplify this little bit down and see what we get. So we've got 1/3 plus 10 take away 25. Alright, so if we work that out then, we've got minus 13 equals 10 take away 25 is minus 15. Add the third to that is minus 14 2/3. There we go, 14 2/3. Obviously you can check that on the calculator, but But there we go, minus 14 and 2/3 plus c. So not the nicest here. How do we get from minus 14 and 2/3 to minus 13? Well, we're going to have to add in those extra 2/3 to get back to minus 14, and then add an extra 1, which is 3/3. So there's 5/3 there that we need to add for c. So our value of c is going to be 5/3. There we go, that would have to be 5/3, there we go. Obviously you could add 14 and 2/3 to negative 13 there, and you'll get your 5/3, or 1 and 2/3. There we go, there's our value of c, and obviously to finish this off we just need to plug it back into the original equation up there for our value of c. So for our final answer here, let's just write this up here, we get y equals 1/3 x cubed plus 10x minus 25x to the minus 1, and then plus 5/3. There we go. And obviously you could write that as a decimal as well if you wanted, but obviously when it comes to thirds I tend to just leave it as a fraction rather than having any recurring decimals in there. But there we go, there's our final answer, that's our final question, and there's an introduction to integration for you. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.